Am I audible? Am I audible, guys? Please reply if I am audible. Please reply if I am audible. Okay, perfect. So let's start. This is the third session on permutation and combination. We have already discussed a lot of concepts. The pending few concepts I will be discussing in today's session with the help of a lot of examples. Okay. So this is something about us, something about me. Okay. So before I start this kind of questions, I'll just discuss a small concept. That is something that I had to discuss here. This is permutation. I guess there was a typing mistake. Anyways, so the first kind of question that was not discussed in the last session, I'll discuss first that. Okay. So if there are 5 letters and 4 letter boxes. Okay. There are 3 rings and 5 fingers. Okay. And things like that. Okay. So in such a concept, what concept we need to follow is, the concept is hen to the power of egg. The concept that we need to follow is hen to the power of egg. What does that mean? That means whichever is the base, okay, which is more constant kind of a thing, okay, that we have to keep in the base, and whatever might vary, okay, depending on different events, that we have to keep in the power. Okay. For example, in a town, what do you feel would be more constant? The letters coming to into the letter boxes, or the letter boxes in the city? Which would be more constant? Obviously, the letter boxes would be more constant. So, in how many ways can 5 letters be put into 4 letter boxes? The more constant thing is the letter boxes. So, the answer would be 4 to the power of 5. Okay. The next, 3 rings and 5 fingers. Okay. If there are 3 rings, which is supposed to be more constant throughout the life of an individual? The rings that he wears, or the fingers that he is going to have? Obviously, the fingers are more constant. So the answer would be 5 to the power of 3. Okay. Or there are 4 awards and 12 students. Okay. If now this question will have to give us a complete information kind of a scenario. Like, it has to give us that how many awards can be given to each student. If it says that any number of awards can be given to each student, then what would become my answer? My answer would be that because what is more constant? The more constant thing are the students. Okay, so 12 to the power of 4 would become my answer. But in case if says that every student can be given only one award, then the answer would be different, right? Then the answer would be different, because now for the first award I have 12 options. For the second award I will have 11 options. For the third award I will have 10 options, and for the last award I will be having 9 options. This would be in the scenario when one award, or I should say one student, can get only one award. Then this would become my answer. Then this would become my answer. Okay. But if any number of awards can be given to any number of people, if any number of awards can be given to any number of people, means a particular student can get any number of awards. He can also get 4, he can also get 3, 2 or 1 or none also. Then this would become my answer. Okay. Okay. Understanding? This is the first concept which I wanted to start with. Okay. Now let's solve the first question now. How many 4-digit numbers can be formed using the digits 0, 1, 2, 3, 4, 5 if repetition of digits is allowed? Okay. In the last session we did not discuss repetition being allowed, so we'll discuss it now. Now here in this place, what all can come? Sorry. In this place I can place 5. 1, 2, 3, 4 or 5. Okay, can I place 0? Yes, I can. Sorry. So I have to form a 4-digit number. What all can I place here? Sorry. I can place either of these 6 numbers. So I have 6 options for this. Similarly for this place also I have 6 options. For this 6 options. But for this place, can I place a 0 here? No. 0 is not allowed. So what all can I fill? I can fill 0, 1, 2, 3, 4 or 5 only. Right? I can fill 0. I cannot fill 0. I can fill 1, 2, 3, 4, 5. So I have only 5 options here. Okay. Now just like the last concept, what will I put in between? A sign of multiplication. Sorry. A sign of multiplication. So what will become my answer? 5 6 are 30 and 6 6 are 36. Okay. So 6 3s are 18. 1080. So in total, how many ways can I do this arrangement? I can do it in 1080 ways. Okay. In the above problem, for how many of the numbers are odd? How many of the numbers are odd? Now, for a similar kind of concept, now in this place, what all can I keep? Okay. Okay. What all can I keep? I can keep either a 1 or a 3 or a 5. Okay, ठीक है. I can keep a 1, a 3 or a 5. I cannot keep a 0, 2 or a 4. Understanding my point? Similarly for this place, so in this place I can keep 3, right? Right? In this place I can keep any of the 6. In this place also I can keep any of the 6. Okay, so in this place I can keep any of the 5. I cannot keep a 0 here. Okay, I can keep 1 to 5, any of these 5. So this would become my answer. Okay, so this would become my answer. So 5 6 are it's 30, 6 3 are it's 18. So the answer would be 540. Now, are you able to see a peculiar kind of a concept here? And that is the total numbers were 1080 and the odd numbers were 540, which is very logical also. Why? Because either a number can be odd or even. Okay, either a number can be odd or even, right? So half of the numbers would be odd and half of the numbers would be even. Doesn't it make sense? Yes, I think it does. Okay, so coming to the next question now. If all the words, not necessarily meaningful, that can be formed by using all the letters of the word alert, are arranged as in a dictionary, the 25th word is. Okay, as I told you, the second concept that I had to discuss in this particular class was rank. Okay, okay, rank. Now how do we solve rank based question? Okay, this is called actually the rank. Okay, so in this question what can I write? I need to say that if I make all the words using these words, okay, all the words would be starting with a A. Okay, all the words would be starting with a A. Okay, the first words would be starting with a A. Now after A, in alphabetical order, what would be coming? After A, in alphabetical order, what would be coming? Obviously E would be coming. But if I have to go up till the 25th word, what do I actually have to do? What do I actually have to do? I have to say that how many words can be starting with a A? How many words will be starting with a A? Okay, so in the next place I have 4 options. In the next place I have 3 options. In the next place 2 options. In the last place 1 option. Okay, so I have 24 words. Okay, I have 24 words. So if the 24 words are starting with a A, so doesn't that mean that the 25th word would be the just next word? Okay, so the next word would be starting with what comes after A in this sequence, because A is the first letter. Okay, this is the 5th letter, this is the 12th letter. Okay, this is I guess the 18th one, and this is the 25th one, 20th one, sorry, right? This is the 20th one. Understanding my point? Okay, now so after 24th one, what letter would be? It would be starting with a E, and just after that, if 5 is coming, then alphabetical order, what would be coming? The one with a 1 would be coming. Then the one with a 12, 18 and 20 would be coming. Okay. So what is 1? It is A. What is 12? It is L. Okay. What is R? It is 18th. And what is C? So EALRT is going to be my 25th word. Understanding my point? Understanding my point? So, just to take more examples for you, okay, just to take some more examples for you, if I say, what are the total number of words that can be formed? I have 5 options for this. Sorry. I have 120 options. I have 120 options, right? Okay. So if I say something like this, then that what would be the, let's say, the 100th word, just for practice. Okay. So how would I solve this? Just see, if instead of 25th, I am asking what is the 100th word. Okay. So now I know A is the first alphabet, L is the 12th, E is the 5th, R is the 18th, and T is the 20th. Okay. How do you remember that? One small concept, that is E Jyoti. The small concept is E Jyoti. Okay. E Jyoti means this is the 5th one, this is the 10th one, this is the 15th one, this is the 20th one, and this is the 25th one. Everything else you can just compare and solve. Okay. One suggestion, use this. I think you will be able to understand. Okay. So because I knew that T would be 20, so RST. RST means because T is 20 and just 2 before that is R. So I will put 18th there. Okay. So if I have to find the 100th word, what will I say? What is the first letter? Okay. So starting with A, I have 4 into 3 into 2 into 1. I have 24. Similarly, starting with E, the next would be E in the line. Right? Because after 1, 5 would come. After 5, 12 would come. After 12, 18. And after 18, 20. Understanding? So now, starting with the E, also 24. Starting with the E, also 24. Starting with a 12, or that is L, also 24. Starting with R, also 24. So, didn't I get 12 into 8 or 24 into 4? That would be 96. So, 97th one would be starting with a T, that means. Okay. The 97th would be starting with a T. 97 onwards would 97 till 120 would be starting with a T. So after T, what would be the first one that would be coming? A, in alphabetical order. So what are the ones which what are the words which are starting with T and A? How many words would be there? Because if T and A is gone, then L, E and R is left. So that means 3 into 2 into 1. There will be 6 of them. There will be 6 of them. So I am sure that my word is after 96, but it is before 3 into 2 into 1, that is 6, that is before 102. So it is supposed to start with a TA only, right? So after TA, what will come? E will come. After TA, what will come? E will come. E will come. So after E, I have 2 into 1, 2 options. So 96 plus 2, 98 done. Right? So what would be the 99th one? It would be starting with a, after E, what will come? A L will come. Okay. So this would be the what would be the 99th one? After L, E would come, and after E, R will come. This will be the 99th word. So what will be the 100th word? It will be TAL. It will be TAL RE. Yes. This would be the 100th one. Okay. This would be the 100th word. Understanding my point? Now, this is the second type of question which can come out of the concept called rank. Now, the third question which can also come from the concept of rank is, what would be or what is the rank of the word REATL, realt. Okay. If it asks us that what is the rank of this particular word, then what would I say? I need to find out from where it starts, right? So after A, E would come, after E, L would come, and then R will come. Okay. Starting with A, I have 24, 4 into 3 into 2 into 1. Similarly, 24 and 24. Right? So 72 are done. So, and after that, R will come, but I am sure that R, how many words are starting with a R? Again 24 only. So that means my answer would be little more than 72 and less than 96. Okay. So I'll say after R, what is the first letter which will come? Obviously A. So how many of them are starting with a? How many of them are starting with a? They are going to be 3 into 2 into 1, 6. After A, what will come? Because this is not starting with R. After R, it's E which is coming. Right? So after A, what will come? The next one would be RE. And this is what I was looking for. After E, what will come? Obviously A. Okay. And after A, L will come. And then T will come. Okay. And after this, REA, T and L. If I will make the choices. Okay. So this is 72, then 6, and then 1, and then 1. This would be the summation would become my answer. Okay. So 72 plus 6 would be 78 plus 2, 80. So the 80th word would become my answer for which letter, what is the rank of the word realt. Not realt, REATL. Okay. So this was the second concept I wanted to discuss here. And all the type of questions that can come from this particular topic. Okay. Next. This I have already discussed. In how many ways can 4 letters be dropped into 5 letter boxes? What is going to be more constant thing? The letter boxes. So my answer would be 5 to the power of 4. Okay, and not 4 to the power of 5. Okay, why so? I've just discussed in the starting of the class. Okay, I hope I am making sense to you now, right? A question paper consists of 6 multiple choice questions, and each question has 4 choices. The number of ways in which one can attempt all the questions. Okay, so it's something like this: question 1, question 2, question 3, question 4, question 5, and question 6. Right? Option 1, option 2, option 3, option 4. Okay, so if a person is supposed to attempt all the questions, then what can he do with the first question? No one is concerned right now. It's the correct answer or the wrong answer. Or the only option is in how many ways can he attempt the first question. He can attempt it in 4 ways. He can either mark option 1 or option 2 or option 3 or option 4. Right? Right? Similarly, for the next question also 4 options. 4, 4, 4 and 4. So what would become my answer? Will it be 4 plus 4 plus 4 plus 4 plus 4 or multiply? Obviously multiply, because after the first question he have to attempt the second. Have to means multiply. So the answer would be 4 to the power of 6. Okay. This would become my answer to the 4th question. Now, this is a nice question. Please try to solve it. Please try to read it and solve it. So what are palindromes? Okay. The numbers or the words which, when seen from left to right and right to left, give us the same answer is something which I call a palindrome. Okay. For example, the word amma. Okay. The word amma, what it will be? A palindrome. Right? You read it from here to here or from here to here. It would be AMMA and AMMA. So it is a palindrome. Okay. The word like Nitin. NITIN and NITIN. Okay. The number 1, 2, 3, 2, 1. A palindrome. Here also 1, 2, 3, 2, 1 and 1, 2, 3, 2, 1 from this side also. Okay. So this is a example of a palindrome. Now let's read the question. A 9-letter password is formed using the letters of these words if repetition of letters is allowed. See, if repetition is not allowed, you can never form a palindrome. Understanding my point? Okay. How many of these passwords are palindromes? Okay. To make a palindrome, I'll just explain one small concept here. A palindrome, I just mentioned here, Amma and Nitin, and there was a specific reason why I explained that. Okay. The number of alphabets this word has is 4. And this has is 5. So please listen to me very properly. If it is a even, if the number of letters are even, then what will happen? In the middle would be not a particular word, but would be a partition. And to the left of that and to the right of that, exactly the same words would be used. Something like XY and YX for a 4. And let's say for a 8, it would be something like A, B, C, D and D, C, B, A. Understanding my point? But in the case if the number of letters or alphabets are odd, then in that case there will be one particular word which is not repeated, and to the left of that and to the right of that will be the repeated ones. Okay, something like XYZ and YX. Okay, in the case of it being 9, it would be something like ABCD and DCBA. These would be the left and the right of it, and E in the middle would be the one which did not get repeated. Okay, instead of writing D, I wrote B here. Sorry for that. This would be DCBA and DCBA this side. Understanding? Understanding my point? Okay. Okay. So now, what is he asking us? I have to use the words. How many letters are there? 1, 2, 3, 4, 5, 6, 7, 8 and 9. So there are 9. Okay. Okay. So there are 9. That means in this place, how many can I keep? I can keep 9. But if in this place I have kept any of these 9, that means in this place I have only one option now. Okay. Similarly, in this place I can again keep any of the 9, but who said that A cannot be equal to B? Understanding my point? Who said that A cannot be equal to B? Right? So, but if I am keeping any of the 9, then here there is only one option. Similarly, here also any of the 9, but here only one option because this is supposed to be equal to this. Here any of the 9, but this is supposed to be exactly the same as this. Okay, and here again any of the 9. So in total, how many ways can I do that? The answer would be 9 to the power of 5. The answer would be 9 to the power of 5. Okay, so this would become your answer. But in case if it would have asked us that the first 5 letters are supposed to be different, if it would have said that how many of the words can you form if repetition is allowed, but first 5 letters or alphabets are distinct. Okay, then how many of these passwords are palindromes? Okay, or how many palindromes can be formed? Okay, something like this. So what would become my answer? In that case, my answer would be if this is A, this is A. If this is B, this is B. If this is C, this is C. If this is D, this is D. And this is E, which is a distinct one. Okay. For this place, I have all the 9 options from A, E, G, I, N, R, S, T or U. Let's say I have taken a G. Now in the place of B, I cannot place G now. So I have 8 options. In the place of C, I cannot place, let's say I have taken A now. So I cannot place G or A, but I can put the rest of the 7. Let me take N here. So now in the place of D, I cannot place A, G or N, but I can place all the other 6. And if the last one that I took was U. So now in this place, In this place, I can place any of the 5. Understanding my point? So, whatever is A is supposed to be coming here. So, only one option, one option, one option, and one option. So, this would have been my answer to the question if it would have been something like this. Okay. So, palindrome based question also done. Okay. So, as I told you that this session we will be discussing most of the questions which we did not do in our last session, and that is the reason I wanted to take the third session and the last session based out of permutation and combination, so that all our concepts get cleared to in the totality. Okay. I humbly actually regret being ill, so that is why you have to listen to more of my sneezing and less of teaching. But I hope I am making sense to you, and the session is useful for you. Okay, let's move ahead, guys. 100 books are to be divided equally among 5 boys. Okay, there are 100 books. Okay, in how many ways can this be done? So now, the first thing is, are these books distinct? The first question is, are these books different? Right? So, if they are different, so what would become the answer to this particular question? It would become, because it is not mentioned, so we have to assume them to be different. Okay. If it would have been identical, then it would have been a different question. I'll explain that also. Now, the first part, the answer would be 100 factorial divided by 20 factorial, 20 factorial, 20 factorial, 20 factorial, and 20 factorial. Okay, because total number of arrangements divided by the first person getting the 20 books. Okay, in what order is he going to get is something that we are not concerned about. Anyways, those 20 books are going to go to this guy only. So, in whatever order you give, that doesn't matter. And that is why the 20 books given to the first guy, first boy, 20 books given to the second boy, 20 books given to the third boy, 20 books given to the next boy, and a 20 books given to the next boy. That is why this would become my answer. Okay. Okay. One more way to think about that is, I pick up the 100 books, okay, and choose the 20 books to be given to the first boy. Okay, I gave that 20 books to the first guy, and now I am left with 80 books. So I pick up the second boy now, and I choose the 20 books that I am supposed to give to the second boy, and then I choose the next of the 60 books, and then I pick up the 60 books and I choose the 20 books I need to give to the third guy. Then I am left with 40 books. Then I am left with 20 books. Sorry. Okay. Okay. So what would this be? 100 factorial upon 20 factorial into 80 factorial multiplied by 80 factorial upon 20 factorial into 60 factorial. NCR is n factorial upon r factorial into n minus r factorial. Okay. 40 factorial upon 20 factorial into 20 factorial. And this is anyways 1. Okay. So what will I see here? 80 gone with 80, 60 gone with 60, 40 gone with 40. Are you able to see the same answer coming? 100 factorials remaining in the top, and 20 factorial, how many of them are coming? 1, 2, 3, 4 and 5. Understanding my point? I hope I am making sense to you. one question that if you are having 20C20, how did I put 1? Remember guys, I told you NC0 is 1. NCN also 1. NC1 N. And NCN minus 1 also 1. And what did I deduce? NCR is equals to NC N minus R. Selecting R people means rejecting N minus R people. Okay, so they would be equal. Why so? If I have 10 friends and I want to invite none of them, then my answer would be one way. I'll not call anyone. If I have 10 friends and I want to call all 10 of them, so my answer would again be 1. I'll ask all of them to come. So NC0 and NCN is one way. Okay. If I have 10 friends and I want to call one of them, then I can call, I have 10 options, and that is why NC1 would be 10 or 10C1 would be 10. Same way, what is NCN minus 1? That is, if I don't want to call one friend, that means I am calling 9 friends. Okay. If I don't want to call one friend, then I am calling the 9 friends. So 10C9 would be the same as 10C1. I hope I'm making sense to you. My humble request, please try to attend all the questions, and from the first session, the second session and the third session. If you will see all the 3 sessions, I am very confident that your concepts of PNC would build up very strongly. Okay, so if you have not seen any of the session, please go back and see those sessions. Okay, I'll try to make as easy these sessions for you if you are directly seeing the third session. But if you have an option, then please go back and see the first and the second session. Then this session would make a lot of more sense to you. Okay. Okay, let's move ahead. In how many ways can 100 books be divided into 5 equal parcels? Okay, so why is this question and this question different? Okay, why is this question and this question different? It is different because the 5 boys cannot be identical. The 5 boys cannot be identical. Okay, they all will be having a distinct identity. So my answer was 100 factorial divided by, so the answer for the first part was 100 factorial upon 20 factorial to the power of 5. But if I have to divide them into equal parcels, that means, yes, it would be 20 factorial to the power of 5, just like the last question. But what will also not matter? Which parcel is given to this or this or this or this. So what also doesn't matter? In what way I am keeping these 5 parcels. Okay. So the first place I have 5 options, the second place I have 4 options, third place 3 options, next place 2 options, the last place 1 option. So this also doesn't matter, and that is the reason I have to divide it by 5 factorial also to get my answer. Okay guys, now let me see the next question. Okay, this is not based on that concept, so I'll frame some more questions to make you more confident in this particular topic. Okay, the third part, I have 100 books. Okay, now I want to make let's say 5 parcels of 15, 10, 25, 35. Okay, this would become 60, 70, 85 and 15. Or let me say 12 here and 18 here. Okay, that would clear more of your doubts. Okay, so just let me check. 12 plus 10 is 22, plus 25 would be 47, plus 35 would be 82, and plus 18 would be 100. Yes. So if this question comes, okay, then what would be my answer? It would be 100 factorial upon 12 factorial into 10 factorial into 25 factorial into 35 factorial into 18 factorial. Okay. Into 1 upon 5 factorial? No. Why? Because now these parcels are not identical in number. They individually have their own identity. They individually have their own identity of having some or of being called. Let's say the first box will be called the box having 12 books. The second box would be called having 10 books. The third box 25 books, the fourth box 35 books, and the fifth box 18 books. So because it has its own identity now, okay, so that means we don't have to jumble them up. Okay, in the first question we did 1 upon 5 factorial because every parcel was having 20 books, so it can be jumbled up. Okay, right? Fourth, if I have 100 books, I need to divide into 5 parcels of 15, 10, 25, 35 and 15. Now if I would frame this question, please pause the video and try to solve it. Then my answer would have been 100 factorial upon 15 factorial, 10 factorial, 25 factorial, 35 factorial and 15 factorial into 1 upon 5 factorial? No. Okay. But it would be 1 upon 2 factorial, guys. Why? Because this 15 and this 15 parcel, they can be interchanged. Okay. So their order does not matter to me also. And that is the reason I'll do 1 upon 2 factorial here. Understanding my point? Understanding my point? Okay. So let's move to the 7th question now. Now try to solve this question. Okay. I have discussed this concept already, but still I would like you to solve the question first. Please write in the chat box, students, if you have any doubts or you want to say something. Okay. If you want to say something, if you want to ask something, please write in the chat box so that I can know what you want to ask. Okay. Let's try to solve this question now. Okay. Of 20 points on a plane. Okay. A plane is something which is of 2 dimension. Okay. Any 2-dimensional figure is called a plane. 6 are collinear. What did I tell you about being collinear? I told you if any 3 points lie on a same straight line, they are called collinear. Any 2 points are always collinear. Okay, because what did I tell you in the last session? From one point, how many lines can pass? Infinite. From one point, infinite lines can pass. From 2 points, only one line can pass. And if from more than 2 points a line is passing, those points are called collinear. Those points are called collinear. Okay. So let's try to solve this question now. 6 points are collinear. So 1, 2, 3, 4, 5 and 6. Okay. Rest 14 of them are non-collinear. That means 1, 2, 3, 4, 5, 6, some 7, 8, 9, 10, 11, 12, 13 and let's say 14. Except for the triplets formed from among these 6 points, no other triplet of points is collinear. Okay. Try means 3. Okay. So what do this line means? Except for the triplet formed from among these 6 points, that means, and if you pick any of these points, any of these P1 to P6, if you pick any of the 3 points, all of them would be collinear. If I pick P1, P4 and P6, P1, P4 and P6 are collinear. Okay, this is what he mean. Okay, no other triplet of points is collinear, means none of the other points are collinear. Okay, let's name them. Okay, N1, N2, N3, N4, N5. They might look collinear, but they are not. None of them is collinear. I'm just explaining it for explaining to you more properly. Otherwise, I would have directly solved it also. Now, what is he saying? By joining these 20 points, how many straight lines can be formed? Okay, he is not asking us that you have to join all these 20 points. By he actually means by joining any of these points, how many straight lines can be formed? He is asking you. Okay. So how many straight lines can be formed, guys? Okay. Before that, you should know a difference between what is a line and what is a line segment. Okay. Something which comes from infinity and goes to infinity is called a line. Okay. And a part of a line which has some definite or fixed length is called a line segment. Line comes from infinity and goes to infinity. Okay. And from that coming from infinity and going to infinity, there if you take a particular portion, that is called a line segment. It has, so line segment has a definite length. Okay. So how many lines can be formed? How many straight lines can be formed? If I choose, in how many ways I can actually make a line? I can make a line from N1 to N14. If I take from N1 to N14, if I take any 2 points, I will form a line. From N1 to N14, if I take any 2 points, I will make a line. Right? So that would be nothing but 14C2. Choosing 2 points out of those 14 non-collinear points, I will be able to make a line. Right? And choosing 1 point from P1 to P6, choosing 1 point from P1 to P6 and from N1 to N14, if I also choose 1 point, okay, that will also form a line. So what would that be? 6C1 and 14C1. Right? I'll just make it for you to understand. So N1 to N14 means something like this. Something like this. Something like this. Okay, P1 to P6 1 point and N1 to N14 1 point, something like this, something like this, something like this, right? This or means plus. Plus there is already one line which is formed. There is one line which is already formed with the help of this P1 to P6. There is a one line which is coming from infinity and going to infinity. So this is one way of solving it. Okay, this is one way of solving the first part. Or the second part to solve this particular question could have been, okay, so let me solve this also. What is 14C2? It would be, I'll just solve it here. 14C2 would be n into n minus 1 upon 2. So 7 into 13 is how much? 91. 6C1 is 6 and 14C1 is 14. So 14 into 6, right? 84 plus 1. So 4, 5, 6, okay, 176. Okay, so in total 176 would become my answer if I solve it using the first logic. Okay, so 176 is my answer. One more way of thinking like that could have been solve the total ways and subtract it by not possible. Okay, so what are the total lines that I could have formed? It would have been 20C4. There are 20C2. Sorry, there are 20 points, and out of them I have to choose any 2 points. Okay, so 20C2 minus from which points lines are not possible. Distinct lines are not possible, I should say. From P1 to P6, if I choose any 2 points, from these P1 to P6, if I choose any 2 points, that would not be a distinct line actually. That would be one and the same line. So if I subtract 20C2 by 6C2, I'll be able to remove all the lines forming from P1 to P6, which were not supposed to happen. But in that case also, I have to have one line for sure. Why? Because that particular one line which is being formed from P1 to P6 is supposed to be taken. So 20C2 minus 6C2 plus 1 is supposed to be my answer. I hope I was able to make sense to you. Okay, how to solve 20C2? It would be 20 into 19 n into n minus 1 upon 2. That would be 190 minus, what would be 6C2? It would be 6 into 5 n into n minus 1 upon 2. That would be 15. So 190 minus 15 would be 175, and 175 plus 1 would be 176. Okay, giving the same answer? Yes. So that means my method is correct. Okay. Okay. Now, please see the next part and try to do it yourself before seeing the solution. Okay. The solution, the sessions are just to help you in start thinking the way PNC wants you to think like. Okay. And this would become the most interesting topic for you. Students tend to actually leave this session and go, leave this portion and go for their CAT examination, because this is not the way they are being taught. Because we are teaching you in this particular way, so we expect you to score from this particular portion. Okay guys, so our agenda is to make you score this section to be the most scoring section for you. Okay, because if you are not thinking and then also you are preparing for CAT, if you want to mug up, CAT is not an examination for you. Okay, go to the biology sector. Mugging up can work there, but it will not work here. Okay, you have to learn few formulas, but everything is based out of concepts. Okay, so if you are able to build up your concepts and have a thinking kind of a methodology, then CAT is an examination for you. As we all say, that CAT is not difficult, it's just a different examination from all the others, and this is what we expect from you. Now, how many triangles can we form? To make a triangle, I need 3 points. So, if from P1 to P6, I choose 1 point, and from N1 to N14, I choose any 2 points, or from P1 to P6, if I choose 2 points, and from N1 to N14, I choose 1 point, or from N1 to N14 only, if I choose 3 points directly. Okay, I'll get all the triangles possible. Okay, part A, P1 to P6 1 point and 2 points here. Does it make a triangle? Yes, it does. Okay, so what answer will I get? 6C1 and 14C2. Next, P1 to P6 2 points, P2 and P3, and N1 to N14 1 point also makes a triangle. Yes, so that would be 6C2 and 14C1. Okay, and if I take directly 3 points, from these 14, then also it becomes a triangle, something like this, and this would be how much? 14C3. This plus this would give me my answer. Okay, so what would be my answer? 6C1 into 14C2, or 6C2 and 14C1, or 14C3. Okay, what did I not take actually? I took choosing 3 points out of the 6 points which are P1 to P6 is the only thing that I did not took. So this or total minus not possible. So total would be 20C3. From the 20 points, take any 3 points. Okay. This is the total cases which are possible. But something which was not possible was from P1 to P6, if I take the 3 points, it would not be a triangle. It would actually be a line. And the same line. Okay. So this would also give me the same answer, guys. Okay. I don't think I need to actually solve it and give you the answer. The concept was the major thing I wanted to discuss through this particular question, and that is why we kept this question in place for you. Okay. Now, let's move to the next question. The number of diagonals in a regular polygon of 10 vertices is, okay. In our first session, we discussed this particular question, right? And what was the answer? If the polygon has 10 vertices, okay, if there are 10 points which are non-collinear, okay, So these are point number 1, point number 2, point number 3, point number 4, point number 5, point number 6, point number 7, point number 8, point number 9, and point number 10. No three of them is collinear. This is what the way to build a polygon is. Okay. So how many lines can be formed? If this would have been a question, there are 10 non-collinear points. Just like in this particular case, there were 14 non-collinear. So how many lines we were able to form through them? It was 14C2. It was 14C2. So from these 10 points, how many lines can I form? 10C2. Right? From these 10 points, how many lines can I form? 10C2. Out of the 10C2 lines that will be formed, okay, how many of them are, there can be two things. It can either be a side or it can be a diagonal. These are the only options possible. Right? See, if from P1, how many lines can I make? 1, 2, 3, 4, 5, 6, 7, 8, and 9. So 9 lines can be formed from P1. Okay. Out of these, 2 of them were what? Sides. Out of them, how many of them were sides? 2 of them were side. P1 to P2 was a side and P1 to P10 was a side. Okay. From P2, I'll not make P1 because it is already made. 1, 2, 3, 4, 5, 6, 7, and 8. From P2, I could have made 8, and out of them only one was a side. That was P2 to P3. Okay, because I did not make P1 to P2 again. So okay, so I could make only one, right? From P3, if I see 1, 2, 3, 4, 5, 6, and 7, I could make 7, but out of them only P3 to P4 was a side. Similarly for P4, I'll get answer as 6, one of them side. P5, 5, one of them side. P6, I'll get 4, one of them side. P7, 3, one of them side. P8, 2, one of them side. P9, 1. Okay, from P9 I will be able to make only one line, that is also a side. Okay, so how many total sides will be there? Obviously 10 I knew from the start, but just to make you think, the question is expecting you to think like. Okay, from P10 I cannot make a new line, everything would be already made. Okay, understanding my point? Understanding my point? Any doubts? Please reply the chat box if you have any doubt. Okay. So, how many of them are sides? 2, 3, 4, 5, 6, 7, 8, 9, and 10. Right? So, if I would have said directly also, you would have understood. Because in a 10-sided polygon, how many of them are sides? 10 of them are sides. But in what way did I teach you this concept? I taught you with the concept of shaking hands. Okay, if there are 10 friends, okay, and so how many handshakes will be there? That was, if there are 10 friends in a party, how many handshakes would be there? The number of handshakes would be 10c2, right? Or if there are 10 friends, then the first friend would be making 9 handshakes, then the second one would be making 8, 7, 6, 5, 4, 3, 2, and 1. And the last one would be making 0 handshakes because everyone would anyways be making a handshake with him. Okay, so 10c2, 10 of them were sides. That means the number of diagonals would be 10c2 minus 10. And that would become your answer. Okay, so the general formula becomes n-sided polygon. So nc2 would be a number of lines can be formed, minus n would be the number of sides that will be there. Okay, so nc2 minus n would become my answer to this particular question. Okay, I guess I was making sense to you. Now, next question. On an 8x8 chessboard, the number of squares of all sizes is. Okay, so I have already discussed this question. I'll not again spend the same amount of time here. I'll expect you to watch the first session that I discussed with you, and from there you can understand the concept. Okay, but the answer was 8x8 chessboard, 8x8 size, 7x7 size, 6x6 size, 5x5 size, 4x4 size, 3x3 size, okay, 2x2 size, and 1x1 size. 8x8 size was only 1 square, and 1x1 size was 64 squares. Here there were 4, here there were 9, 16, 25, 36, 49. So the summation of all of them would become my answer, and this is nothing but 1 square plus 2 square up till 8 square it is. And what is the formula for this? It is n into n plus 1 into 2n plus 1 whole upon 6. The foundation discussion for this type of question I discussed in the first class, so please go back and see the first class if you want to have the in-depth discussion of how this came. Okay, I made the square also, and on the square I made you explain this particular concept. Okay, so it would be 8 because n is 8 here. 8 plus 1 into 8 into 2, 16 plus 1 upon 6. Okay, so this was 8 into 9 into 17 upon 6. 2 3s are, 2 4s are, and 3 3s are. So this was 12 into 17. 204 becomes the answer to this particular question. Okay, how many rectangles? So to make a 8x8 chessboard, I need 9 lines like this. To make a 8x8 chessboard, I need 9 lines like this, and also 9 lines like this. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Then only a 8x8 chessboard is formed. To make a rectangle, what do I require? From the 9 vertical lines, I need to choose any 2 lines, and from the 9 horizontal lines, I also need to choose any 2 lines. So 9c2 into 9c2 would become my answer. Any doubts, please reply in the chat box. So 9c2 into 9c2 would become my answer. Okay. Now, coming to the next question. The number of words that can be formed using all the letters of the word success is. Okay. So, again, just a revision of the discussions we had already. So, S is coming how many times? 3 times. U is coming how many times? 1 time. C is coming how many times? 2 times. And E is coming how many times? 1 time. Total there are 3 plus 1, 4 plus 2, 6 plus 1, 7. Okay. So there are 7 letters. Yes, there are 7 letters. So in how many ways I can place them? The answer would be 7 factorial. If all the S are different, all the U are different, all the C are different, and all the E are different, then the answer would be 7 factorial. But because they are not distinct, so how many of them are similar? 3S are similar, so we'll divide it by 3 factorial. 2C are similar, so we'll divide it by 2 factorial. Okay, and this would be my answer. Okay, and this would become my answer. Understanding my point? Understanding my point? Okay, just solve it and get the answer. Okay, it would be 4 into 5 into 6 into 7, and this would anyways be 2 only. So 10 and 6 sevens are 42. So 42 into 10 would be 420. So 420 becomes the answer for the first part. Next part now. Next part now. In the above problem, the number of words in which all the S are together. So if I place all the S together on a bench, let me keep them. So U would be the next one on a single seat, C and C on 2 separate seats, and E on a separate seat. So 1, 2, 3, 4 and 5. In how many ways can I place them? 5 factorial ways. Divided by 2 factorial for what? The 2 C's which are there. Right? And in how many ways can I place these 3S? If they would have been different, then I would have been able to place them in 3 factorial ways. But because all of them are same only, so I'll divide it by 3 factorial. So if I'll not do anything also, then also 5 factorial upon 2 factorial would become my answer. 5 factorial is 120, so 120 upon 2 would be 60. So 60 would be the answer to the second part. Understanding my point? Because all of the S were identical. All of the S were identical. So they cannot be interchanged in such a way that they become a different word. Okay. 11th, the number of non-negative integral solutions, the number of positive integral solutions, and things like that. Okay, so this was a very important concept that I wanted to spend a lot of time in, so that it becomes easy for you. It sometimes comes in the concept of number system. Sometimes these questions come in the concept of permutation combination. Okay, but the logic is the same. Okay, so a simple concept: if I have a few pen in my hand, okay, if I have few pen in my hand, and if I want to divide it among 2 people, what will I do? I'll put one partition, and I say, to the left of this, whatever is there, the number of pens are there, you keep, A person keeps, and to the right of this, how many pens are there, B person keeps. So to divide it among 2 persons, I need how many partitions? I need 1 partition. To divide among 2 persons, I need 1 partition. To divide among 3 persons, I would need 2 partition. I would need 2 partition. What will I say? To the left of this, A keep, between of this, B keep, and to the right of this, C keep. Okay, something like if these are some things which are kept. If I need to divide among 2 persons, I need 1 partition. If I need to divide among 2 persons, I'll need 2 partitions, right? Right? If I need to divide among 3 persons, actually, if I need to divide among 4 persons, I would need 3 partitions. I'll say this much A keep, this much B keep, this much C keep, and to the right of this much D keep. Okay? Understanding my point? Now, the second thing that you should know is, what do we mean by integers? Integers are positive integers, they can be negative integers, and they can also be 0. Positive integers are called natural numbers. Okay. Or at sometimes they are called positive integers. Okay. Positive integers plus 0 are called whole numbers. And sometimes they are also called non-negative. Okay. And obviously the negative integers are called negative only. Understanding my point? So coming to this question now, it said non-negative integral solutions. That means 0 can be allowed. Okay. So the method I'm going to teach you here is, there are 20 items left kept. These are 20 items kept. I need to divide them into 4 people. So how many partitions do I require? 1, 2 and 3. I need 3 partitions. To the left of this, x1 will keep. Between of this, x2 will keep. Between of this, x3 will keep. And to the right of this, x4 will keep. And the summation would be 20? Yes. Okay. So, how many solutions will come? Now, can I see this question something like, these are i's, not ones. These are some i's. So, there are 20 i's, there are 3 p's. In how many ways can I arrange them? In total, there are 23. So, the answer would be 23 factorial. In total, there will be 23 factorial, because 20 are I and 3 of them are p's. And how many of them are identical? 20 i's are identical and 3 p's are identical. Right? So, this would become my answer. Understanding my point? Understanding my point? So, this would become my answer. Okay, one way to think about that. Okay, the second way we can also formulate a formula. Okay, there are n items. P is the number of partitions. Okay, the number of partitions. Okay, so if I do n plus p, how many items were there? There were 20 items. How many partitions were there? There were 3 partitions, because there were 4 persons. So 4 minus 1, 3 partitions. C, either you put here p or you put here n. It is one and the same thing, because npr is same as np, n minus r. So anyways, n plus p is cp and n plus p cn would also give me the same answer. It would also give me the same answer. Okay, right? So it would be 20 plus 3, 23 c3, which is same as saying this thing. Understanding my point? So this was how to solve non-negative integral solutions. This is how to solve non-negative integral solutions. Now, to solve positive integral solutions. What do we mean by positive integral solutions? I mean that number of items being 0 is not allowed. Number of items that a particular one can keep is being 0 is not allowed. So that means what? Minimum 1 is supposed to be given to everyone. So what I will say is, whatever is the minimum criteria, give it to all of them. Okay, give it to all of them. Okay, whatever the minimum criteria is, fulfill that. Okay, so after fulfilling that, what is left? After fulfilling that, what is left with us? Okay, after I fulfill that, I actually had to do x1 plus x2 plus x3 plus x4. If I have given 1 to x1, 1 to x3, 1 to x4 and 1 to I have given 1 to x1, 1 to x2 and 1 to x3 and 1 to x4, I have left with a plus b plus c plus d. This was 18. I have already given 4 of them, so I have left with 14. And of this, I need to find out now non-negative, integral solution only. Of this, I want to find out only the non-negative integral solution. Why so? Why so? Because guys, now if 1 is already given, so even if a's value would be 0, x1 value would be 0 plus 1, right? So now what it would become? 14 I have 1 1 1 1, 3 I have partitions, so 14 plus 3 would be 17 factorial divided by 14 factorial into 3 factorial, because all the 14 digits or i's would be separate and all the 3 partitions would be separate, okay, or identical in nature. Okay, or as a formula, what did I learn? N plus p cp. What was n? 14 plus how many partitions? 3, c3 will give me the same answer. Now, if I formulate something new question, okay, before formulating a new question, let me simply solve the third part first, and then I'll do some more fluctuations of this particular concept. In how many ways can we divide 10 identical marbles among 3 boys such that each gets at least 1 marble? Okay, so I have m, 4, 5, 6, 7, 8, 9 and 10. Okay, I have to divide it among 3 boys. So partition and partition. 2 partition would make 3 distributions. Now, at least 1 marble I have to give to all of them. If it would have been, this portion would not have been there. Okay, if this portion would not have been there, then what would have been my answer? There are 10m and there are 2p. So the answer would be 12 factorial upon 2 factorial into 10 factorial. This would have been my answer. But because this portion is there, so what will I say? I'll say whatever is the minimum condition, fulfill that. Give 1 m to the first boy, second m to the second boy and third m to the third boy. So 3m or 3 marbles are gone. Now how many marbles are left with me? 7. 10 minus 3, right? So this question is actually nothing but x1 plus x2 plus x3 is equals to 10. Find out the positive integral solutions, or x1 plus x2 plus x3 is equals to 7. Find out the non-negative integral solution. Okay, you can take this question as any of these 2. Okay, so now I am left with only 7, and for these 7, how many partitions I require? I still need 2 partitions. Okay, so n would be 7 now, p would be 2 now, so N plus PCP so 9C2 would become my answer. So 9C2 would become my answer to this particular question now. Understanding? Right? Now, what all more questions can come? It can say A plus B plus C plus D plus E, let's say, because already I have taken 4 and 3, I'll take 5 now. Okay, is supposed to be equal to 25. Okay, A, or I can directly say all of them are even numbers. All of them are even numbers. Okay, so in how many ways can this be done? The answer would be no solution. The answer would be no solution. Why so? Because if all of them are supposed to be even, that means one simple thing. If all of them are supposed to be even, that means one simple thing, which is that even plus even is even. So even plus even plus even plus even plus even would also be even. Understanding my point? So the answer would be no solution. Why? Because 25 is not even. The summation of all the even numbers is supposed to be even. Okay. So this would be no solution. Fifth, if I say that A plus B plus C is equals to let's say 24 now. Okay. And now I say that A, B and C, all of them are even. Okay. So what would be the answer to this? Now it is possible because even plus even can be 24. So if I will say that A is even, so let me call it 2 times of x1. General form of an even number is 2x or 2n. Okay. If I say they are even natural numbers, okay, then this becomes what? Then this becomes x1 plus x2 plus x3 is supposed to be 12. Is supposed to be 12, as well as x1, x2 and x3 are supposed to be natural numbers. So I'll give this statement as something like p plus q plus 1 as equals to 9, because I'll give 1 or 1 1 1 to x1 also, to x2 also and to x3 also. I'll give 1 1 and 1 to all three of them. I'll give 1 1 and 1 to all three of them. So now 3 are gone. So p plus q plus r is supposed to be 9 now. If it is supposed to be 9, then how many ways can I do the partitions? My answer would be there are 9 items and there are 3 people. That means 2 partitions, 1 less. Okay. So my answer would be n is 9, partitions are 2, C2. 11 C2 would become my answer. A very good question. Right? So 11 C2 would become my answer. Right? So this was all things that we can solve with such a question. Okay. One more thing, not very different. Fourth and fifth we have done. Sixth, if I say that x1 plus x2 plus x3 is equals to, let's say, 25, x1 is at least 3, okay, x2 is at least 2, x3 is at least 4, something like this. Then is this a different question? Not very much. whatever is my minimum criteria, just fulfill that. -3, -2 and -4. So basically -9. x1 minus 3, let's call it A. x2 minus 2, let's call it B. And x3 minus 4, let's call it C. This is equals to 14 now. Oh, sorry, 15. 16 actually. So A plus B plus C I am supposed to take as 16. So there are 16 items and there are 3 distribution that I need to do. That means how many partitions I require? 2. So it would be 16 plus 2, 18 C2. I need 16 plus 2, that would be N is 16, partitions I require is 2, so it would be N plus P C P. Okay. Understanding my point now? I hope it is clear now. Okay. Let's try to solve the next question now. This question is also based out of a concept called there are 5 letters and 5 address envelopes in which these letters are to be posted. Okay. Find a number of ways of doing this. Okay. So this is not a question based out of dearrangement. Dearrangement is also a concept which might be we'll be discussing today, or if we'll get a chance in the next class we'll do that. Okay. If the time permits. Okay. So there are 5 letters and 5 address envelopes in which these letters are to be posted. The number of ways that can be done. Okay. So where can the first letter go? The first letter can go in any of the 5 envelopes. The first letter would be having 5 options. The second letter cannot go into that envelope which the first letter has already gone to. So I'll have 4 options. The third letter, 3 options. Fourth letter, 2 options, and the fifth letter, 1 option. So simply 5 into 4 into 3 into 2 into 1. Okay. And that was anyways 120. So not a very different question. Okay. Now, this is the concept that we needed to discuss with you. Okay. In the above problem, in how many ways is or are all the letters posted correctly? All the letters posted correctly, there is only one way to do that. Okay. If L1 was supposed to go in E1, L2 was supposed to go into E2, L3 was supposed to go into E3, L4 was supposed to go into E4, L5 was supposed to go into E5. So there's only one way in which all of them can be posted correctly. Right? Okay. Now, the second part, exactly 4 letters posted correctly. If I am posting the 4 letters correctly, let's say these are the 4 letters being posted correctly. How can this letter be posted incorrectly? Not possible. Not possible, guys. Understanding my point? 0. Okay. Understanding my point? Now, the third part is exactly 2 letters posted correctly. Right? So, out of the 5 letters, I have to choose the 2 letters. 5 letter envelope pair. I have to choose any 2 which I am supposed to post correctly, and there is 3 of them. There is 3 letter envelope pair. I can arrange in total 3 factorial ways, and then comes the formula of dearrangement. Okay. Which is n factorial upon 1 upon 2 factorial minus 1 upon 3 factorial. You have to go on till you this value becomes equal to this value. Okay. For example, I'll just explain. In the concept of dearrangement, guys, the number of dearrangement, let's say it is dn, which is in how many ways can n of them be managed incorrectly. So the total arrangements are going to be n factorial multiplied by, the first would be 2 factorial in positive, next negative, then positive, then negative, and so on till 1 upon n factorial. It would totally depend upon what is the value of n. If the value of n is positive, if the value of n is even, then the last one would be a plus sign. If the value of n is odd, then the last one would be a negative sign. Okay, so this is the formula of dearrangement. Okay, in depth I would have discussed if this would have not been a workshop session, but would actually be a regular session I would have been taken for you, because cat is just in the corner, not even complete 2 months are left for you to give cat. So I'll actually exactly 2 months are left, so I'll not go into the depth of how this formula was derived, but yes, this is a formula that you can remember. Okay, now because I had to do the dearrangement of 3, so that is why this formula came. In the next, no letters posted correctly. No letter posted correctly, that means I have to use the formula of dearrangement of 5. Okay, so I'll have to use the formula of the dearrangement of 5. What would be the formula of dearrangement of 5? Okay, see, d1 to d5 you should remember. Okay, and that would be 5 factorial, because n factorial multiplied by 1 upon 2 factorial minus 1 upon 3 factorial plus 1 upon 4 factorial minus 1 upon 5 factorial. See, this was odd, so the last sign was negative. And this answer you should remember. What is dearrangement of 5? It is 44. Okay. Okay. So this was the concept of dearrangement, and this was the last concept I told you that we'll be completing in a third session, which is a last session based out of PNC. Next session would be probability, actually, which is related to PNC but deals with different kind of concept. Okay, we'll discuss that in totality. This is a formula, please note it down. Okay, now let's see the 14th question. Now there are 5 physics books, okay, 4 chemistry books and 3 maths books. In how many ways can a person select at least one book? Okay, so this is a concept that I discussed in the first session, wherein I discussed the concept with you, like if guys I have some I'm going to a party, or let's say, okay, so in a party are these all the physics books different? Yes, they are. So I'll not call them MM and something like that. I'll name them differently, because if it would have said that all physics books are identical, then it would have been a different question. It would come in the next question most probably. And if it would have said 5 physics books, 4 chemistry books and 3 maths books, that means all of them are distinct. In that condition, in how many ways can I choose at least one book? Okay, so in how many ways can I choose total? Any number of options if I have. What I will think about the first physics books, I have 2 options. Second physics books, again 2, 2, 2 and 2, 2, 2, 2 and 2, 2, 2, 2. So in total, how many options do I have? So 5 plus 4, 9, 9 plus 3, 12. So in total I have 2 to the power of 12 options. Okay, if I have to select at least one book, then I'll do -1, the condition where I did not choose any book. Okay, this would become the answer to the first question. Okay, now if it would have said the second part now, now if it would have said that I need to choose at least one book of each subject, then what would become my answer? 2 to the power of 5 option I have here. Okay, -1 individually here, because I needed to choose one book from physics also. Similarly, this would be 2 to the power of 4, but -1 here. This would be 2 to the power of 3, but -1 here also, because from the physics category I need to choose one book, from the chemistry category I need to choose one book, and from the chemistry category also I need to choose one book. So my answer would be 2 to the power of 5 -1, 2 to the power of 4 -1, 2 to the power of 3 -1. This would become my answer. Okay, now this is the question which has changed now. Identical books. If it is saying identical books, then what does that mean? In how many ways can I choose? It's just like going to a party. If I am standing here, this is the vegetable of paneer. This is let's say a cucumber salad, and this is some Magnum ice cream, let's say. Okay, there's a bucket in which Magnum ice cream is kept. There is a particular bowl in which cucumber salad is kept, and in the third one I have paneer vegetable. So I choose one. How many options do I have of going from this to this spot? I have to cross all the three. So between them the sign of this would come. In how many ways can I move past the paneer stall? I can choose 1, 2, 3, 4, 5 or none. Understanding my point? So I have 6 options. I can choose 1, 2, 3, 4, 5 or none. So I have 6 options here. Okay. For the next one, I can choose 1, 2, 3, 4 and again none. So I have 5 options here. And to the next one, I can choose 1, 2, 3 or none. So I have 4 options here. So 6 into 5 into 4 would have been the answer for if I can choose any number. But because it said that at least one of the book I have to select, so I'll subtract it by 1. So what is 6 into 5? It's 30, and 30 into 4 is 120. So 120 minus 1, 120 minus 1 would be 119. So the first part, the answer would be 119. Understanding my part? Understanding the concept? Now, if it says that at least one of each type I have to buy, then what would become my answer? It would be 6 minus 1, which actually means 5. I can choose 1, 2, 3, 4 or 5. Understanding? Understanding? Now, similarly for C, I can choose 1, 2, 3 or 4. For third, I can choose 1, 2 or 3. So 3 options only here. So it would be 4 options here and 3 options here. So this would be 5 into 4 into 3 directly. That would be 60. So 60 would have become my answer to this particular question. Okay. So I have discussed identical base questions with you. I have discussed different base questions with you. We discussed all the concepts that were required for you to solve and get the answers. Okay. I'll just some additional questions I am having. Okay. Please try to see them and solve them. Okay. If you have any doubts in these questions, please let me know. I'll just write down the answers for these questions so that you know, and if you have any doubts and you are not able to solve, please do not hesitate in asking. The first answer was 81. The second answer is 14. The third would be 15. And the fourth would be 4. Okay. For the next one, this is something which I guess you have already done, and the answer is 27 here. Okay. This you must have discussed in the concept of number system. Okay. This is, I just discussed this concept because this is a concept which I have not discussed till now. Okay. So what was the answer to this? The answer was 22C2. Okay. Why is this the answer, guys? Why is this the answer? This is a similar, though it has derived its concept from binomial. Okay. It has derived the concept from binomial functions, but even if you don't know, just take such a question to be something like A plus B plus C is supposed to be 20. Okay, so what would become your answer? 20 are the items, 2 are the partitions, C2, N plus P, C, P. Okay, so this is the way to remember this concept by. Okay, not very difficult, right? Actually very simple. Now, unbiased dice, in how many ways can the total be? 19. Okay, this concept, again, if you see this particular concept, the answer would be 8C3. Right? Why? Because in a dice, the max score can be 6, or I can say that the score can range from 1 to 6. Right? So, the max score of 4 dice can be 24. Okay. So, but we need the answer as 19 only. We need the answer as 19 only. Okay. So, what I will actually do, I will say that the difference here is 5. Now, this 5 I have to divide among the 4 dice rolls. Where less? Okay, where less is my question. So A plus B plus C plus D is supposed to be 5. Are you understanding my point? I have 4 unbiased dice are rolled. In how many ways can the total be? 19. What can be the maximum total? It can be 24. My total is supposed to be 19. Okay, so what is the value which is lesser? It is lesser by 5. If it is lesser by 5, that means in these 4 rolls, I have to divide 5 only, right? Okay. If A is 1 less, B is 1 less, C is 1 less and D is 2 less, that means what? If A is 1 less, B is 1 less, C is 1 less and D is 2 less. What does that mean? Then the dice roll of 1, I got 5, 5, 5 and 4. Understanding? I got 1 lesser than the maximum value possible. This and 2 lesser than the maximum value possible. This would become my actual value. Okay. Okay. And what there can be 0 less also. Okay. If I get 0 less in the 0 less here, 2 less here, 3 less here, and let's say 0 less here. That is also possible. If I got 0 less, that means I got the maximum value. I got the maximum value. 2 less, that means I got 4. 3 less, that means I got 3. the summation of this would also be 19 only. Okay, you can just cross check. So that means what do I have to find out here? The non-negative. Yes, I have to find out the non-negative integral solution. So doesn't it become a very good question to solve? Yes. How many non-negative integral solutions are there? So this becomes a question which actually infuse the question of non-negative integral solutions. Okay. So please remember this question, a very good question actually. So I have 5 items. I need 3 partitions because I need to divide among 4 people. Okay. And C3. So 8C3 was your answer. Why so? I've just explained. Okay. Though I was just supposed to give you the answers, but because it being a very good question, I wanted to discuss. Okay. And then only complete. Okay. The 5th was again a good question. Okay. It's a 6 by 6 grid. So that means 7 lines vertically and 7 lines horizontally. Okay. How many straight lines can be formed using the dots? Try to solve this. Okay. How many triangles? How many rectangles? How many squares? Okay. If in how many ways can one go from A to C without going through B? One can only go horizontally up, horizontally right, or vertically up, and diagonally north to east. Okay. So please try to solve this question. This was all we needed to discuss with you. This was the last question I'm expected to give you as a task. Please take it as a challenge and try to solve this. Okay. Okay. Thank you guys. This was all we needed to discuss in the concept of PNC. If you face any doubts, please write in the chat box in the whole session that I just completed with you. Any doubts, please write in the chat box. I'll be more than happy to answer. Okay. I'm waiting. If you have any doubts, I'll wait. Thank you, covalent bond. Yes, yes, I will take some rest, but because exactly 2 months are left now for your examination of CAT 21, so I wanted to complete the session because I don't want you all to actually suffer because of me, because I am suffering from cold and fever and all these things. Thank you, beta. Okay. Any other doubts? Perfect. Okay. I'll end the session. Please try to solve the last question that I have given you. Just a minute.